Next question. Question number 97. A thin diamagnetic rod is placed vertically between the poles of an electromagnet. When the current in the electromagnet is switched on, then the diamagnetic rod is pushed up out of the horizontal magnetic field. Hence, the rod gains gravitational potential energy. The work required to do this comes from option A, the lattice structure of the material of the rod, option 2, the induced electric field due to the changing magnetic field, option 3, the magnetic field, option 4, the current source. So a diamagnetic rod is placed between the pole pieces of an electromagnet. So diamagnetism, one of the properties is diamagnetic material. One of the properties of the diamagnetic material is to move away from stronger field to weaker field. It will get out of the magnetic field. That is the property of diamagnetic materials. So when you are keeping a diamagnetic rod in between the pole pieces of an electromagnet and switch on the electromagnet, the diamagnetic rod will try to keep away from the magnetic field. So it is getting away from the magnetic field. It being a rod, it tries to get away from the magnetic field. That's a property of the diamagnetic material. So the magnetic field, when you apply, the diamagnetic rod tries to keep away from the magnetic field. So what is the source of the magnetic field which you are applying? That is the current which you pass in an electromagnet. Therefore, the current in the electromagnet produces a magnetic field. That magnetic field, when applied to a diamagnetic rod, make it to move up. Do you understand that? So you should note the words very clearly, thin, so that it can easily go away, go up. So easily it can overcome the gravitational field. Otherwise, if the rod is very heavy, you will have to apply extraordinarily heavy magnetic field. So the rod is very thin, right? And also some stability factor is included. So thin rod, it will have its stability and it will try to move up. It tries to escape the applied magnetic field. That's the basic idea, it being diamagnetic rod. Understand that? So what is the source? Current source. Option 4 is correct. Okay, next question. An inductor 20 millihenry, capacitor 100 microfarad. Capacitance 100 microfarad and a resistor 50 ohm. Resistor of resistance 50 ohm are connected in series across a source of EMF. V is equal to 10 sin 314 t. 10 sin. The power loss in the circuit is, 4 options are given. Power loss. So it is basically LCR series circuit. Supposed to find, as per this question, you are supposed to find the power loss in the circuit. So the power is lost because of resistances. Therefore, power loss I squared R. I is the current in the LCR series circuit. Current in the LCR series circuit is V by Z into R. This is all, this RMS, this RMS. And you see this V is RMS value, but here whatever V is given, no, that is peak value. Therefore, here you should substitute V as 10 by root 2. V equal to V naught sin omega t. Omega is 314. Vrms 10 by root 2. You are supposed to find Z, substitute for V, R is given to be 50. Simply substitute. So the calculation of Z will be like this. For that you should know what is XL. XL is L omega. XL is known as inductive reactance. L omega, L is 20 millihenry. So 0.02 omega 314. This is XL. So when you calculate this, you are getting 6.28 ohm. Then XC 1 by C omega. So this on simplification will give you 31.8 ohm. Therefore XC minus XL, circuit is capacitative. XC minus XL, 31.8 minus 6.28. So you are getting 25.52 ohm. So Z is equal to formula root of R square plus XL minus XC the whole square root of 50 square plus 25.52 square. You can even take up to one decimal place. So 25.52 the whole square. So this on simplification will give you around 56.1 ohm. That is impedance. Now find, simply put it in this, you know V, you know Z, you know R. Okay. So power loss V by Z into power loss is I squared R. So V by Z square into R. Okay. Therefore power loss V by Z, V 10 by root 2, Z is 56.1 whole square R 50 ohm. Simplify. This on simplification will give you 0.79 watt. So the answer is 0.79 watt. Option 4 is correct. Next question, question number 99. An object is placed at a distance of 40 cm from a concave mirror of focal length 15 cm. If the object is displaced through a distance of 20 cm towards the mirror, the displacement of the image will be 30 cm towards the mirror, 36 cm towards the mirror, 36 cm towards the mirror, 36 centimeters away from the mirror, and 30 centimeters away from the mirror. Okay. Now you can see here, when an object is moved towards a concave mirror, the image will be moved away from the concave mirror. So towards ruled out. So you'll have to find out between the two. Definitely image will move away. These are the given data. Initial position of the object 40 cm from the mirror, focal length 15 cm, then you are shifting it by a distance of 20 cm. Therefore the new distance of the object 20 cm. You are supposed to find the image shift in the image position. How much will be the image moved? For that you should know V2 minus V1. V1 you can find because U1 and F given. V2 you can find because U2 and F given. Subtract. See, in the case of concave mirror, 1 by F is equal to 1 by V1 plus 1 by U1. 1 by f is equal to 1 by v plus 1 by u plus 1 by u, concave mirror. Length means 1 by f is equal to 1 by v minus 1 by u. So 1 by v1 is equal to 1 by f minus 1 by u1, 1 by focal length of the concave mirror negative according to new Cartesian sign convention. So minus 1 by 15, this minus as it is, u1 is 40, that is again minus 40 according to the sign convention. So what do you have now? 1 by 40 minus 1 by 15, that will give you the first position of the image. From that you will get v1 as 24 centimeter. You will get minus 24. Maybe you will write minus 24 centimeter, that is 24 centimeter in front of the concave mirror, v1 initially. Then you will have to find v2. So I will write here v1 is numerically 24 centimeter. That minus symbol indicates it is in front of the concave mirror. Let me find out v2 then, because 1 by f minus 1 by u1. So 1 by minus 15, focal length 15 minus 1 by u1, u1 is present distance is 20, sign convention put minus 20. So this will become the first term, so minus 1 by 15. When you evaluate, this v2 will turn out to be v2 minus 60 centimeter. Minus will indicate in front of the concave mirror, therefore numerically 60 centimeter. Anyway, all numerically. Therefore shift in the position will be 60 minus 24, so 36 centimeter. That should be away, 36 centimeter away from the mirror. Option 3 is correct. Okay, thank you.